Hello, and welcome back to Introduction to Physics. Today we're going to be studying for your lab final. So we covered 11 labs this semester, and there's going to be 2 questions from each of those labs on the exam. It's 100 points, and it is worth 5% of your grade, so it is very important that you do well on this. So the kinds of questions that I'm going to ask you are going to be one, using some kind of measuring device. Could be a ruler, could be a spring scale. So it's something that you have used in lab and you're just going to demonstrate that you know how to use it correctly. Okay, another type of question is going to be a concept question that goes with one of the labs. Another kind of question is going to be a math question where I give you the formula and then you need to be able to plug numbers into it. And then also there will be graphing types of questions where you either have to make a graph or you have to interpret a graph or you need to find the slope of the graph, but something of that nature. Alright, when you opened up this document, you might have noticed that up at the top there was another document that said Introduction to Physics Lab Exam Learning Objectives or something of that nature. Okay, open up that document and then that way you can go along with me as I go through these different labs. So I tried to summarize on that document what I thought was the most important things out of each of these labs. Okay, you do not get to use a note card for this lab, but I will provide on the exam all of the formulas that you're going to need. Now, I'm not going to tell you which formula goes with which lab, but all of the formulas will be provided for you. And then also any conversion factors that would be necessary, I would provide those for you as well. Okay, so let's start with the first lab that is going to be fun with tape. So we did this one early in the semester, and this was the one where you took Scotch tape and you pressed it down onto the table, and then you pulled it up, and then you noticed that it became electrically charged, but you didn't know which way it was electrically charged. Was it positively charged or was it negatively charged? And so that was kind of the goal of the experiment, was to figure that out. So what I want you to know, okay, there's no measurement in that lab, so wouldn't be any questions about that. Okay, but you should know about the 2 different types of charge, positive and negative. Okay, then you ought to know what causes those electric charge. So what fundamental particle is associated with negative charge and what fundamental particle is associated with the positive charge. Okay, then we did some stuff with electrical properties of materials. So I'd like for you to review, or you might need to look it up on Google, that when you pulled up a piece of Scotch tape off the table, it became electrically charged. What kind of electrically charged was it? So did the tape become positively charged or negatively charged? You should be able to find that on the internet. Okay, then we also talked about separation of charge. So that if you've got something like 2 pieces of tape that are stuck together and they are electrically neutral, and then let's say that I pull them apart and that this one becomes negatively charged, what does this one over here have to be? Positively charged. Okay, or I could ask you a question like, let's say that this one over here is negatively charged, and then I have this unknown piece of tape over here, and then when I bring it close to it, the 2 pieces of tape, they repel each other. So what must be the charge then on this piece of tape over here? So questions like that. And then conservation of electric charge. So what does it mean to say that electric charge is conserved? All right, you'll notice that there's no math on this one, so that the questions on this one are going to be strictly conceptual. All right, the second lab that we did was on series and parallel circuits. So we did this one on the computer where we made a circuit. First we made a very simple circuit that consisted of only a battery and a resistor and well, that was it. And then we measured the voltage of the battery, and then we also measured the voltage of the resistor, and then we also measured the current in the circuit, and then we were able to actually calculate the current in the circuit if we knew the voltage and the resistance of the resistor by using Ohm's law. Okay, then what we did was we had two resistors in series, and then we calculated the current and the voltage in that circuit, and then we took the two resistors and we put them in parallel, and we calculated the current and the voltage. We also calculated the total resistance of two resistors in series and in parallel. And then finally, we learned how to take a voltmeter and attach it to that circuit so that we could measure the voltage. And then we learned how to attach a ammeter, a thing that measured current. Okay, so the concepts that you need to know is Ohm's law. You should be able to calculate the resistance, the current, and the voltage in a series circuit. Calculate the resistance, the current, and the voltage in a parallel circuit. And then you should be able to draw a picture showing how you would put the ammeter into a circuit to measure current, and how you would put a voltmeter into a circuit. So all of this is in the lab, so I encourage you to go back through that lab and to read all of this stuff. So I've given you the math formulas for Ohm's law, V equals IR. I've given you the formula for how to calculate resistance in series, so that's the sum of the resistances. And then I've also given you the formula for calculating the total resistance when they're in parallel. So that would be the math concepts that I would want you to know. Okay, I'm going to stop this video here, and then when we come back, we're going to talk about the lab that we did on magnetism.